Mountain formation refers to the geological processes that underlie the formation of mountains. These processes are associated with large-scale movements of the Earth's crust. Mountain formation is related to plate tectonics. Folding, faulting, volcanic activity, igneous intrusion and metamorphism are all parts of the orogenic process of mountain building. The understanding of specific landscape features in terms of the underlying tectonic processes is called tectonic geomorphology, and the study of geologically young or ongoing processes is called neotectonics. To understand mountains we must first know more about their geomorphic history. In most mountain studies this is not done, instead the rock structures inside the mountains are described in detail, with the tacit assumption that whatever made the structures also made the mountains. This assumption is not warranted. Types of mountains. There are three main types of mountains: volcanic, fold, and block. A more detailed classification useful on a local scale predates plate tectonics and adds to the above categories. Volcanic mountains equals. Movements of tectonic plates create volcanoes along the plate boundaries, which erupt and form mountains. A volcanic arc system is a series of volcanoes that form near a subduction zone where the crust of a sinking oceanic plate melts. Most volcanoes occur in a band encircling the Pacific Ocean, and in another that extends from the Mediterranean across Asia to join the Pacific Band in the Indonesian archipelago. The most important types of volcanic mountain are composite cones or stratovolcanoes and shield volcanoes. A shield volcano has a gently sloping cone due to the low viscosity of the emitted material, primarily basalt. Mauna Loa is the classic example, with a slope of 4°-6°. The composite volcano or stratovolcano has a more steeply rising cone, due to the higher viscosity of the emitted material, and eruptions are more violent and less frequent than for shield volcanoes. Besides the examples already mentioned are Mount Shasta, Mount Hood and Mount Rainier. Fold mountains equals. When plates collide or undergo subduction, the plates tend to buckle and fold, forming mountains. Most of the major continental mountain ranges are associated with thrusting and folding orogenesis. Examples are the Jura and the Zagros Mountains. Block mountains equals. When a fault block is raised or tilted, block mountains can result. Higher blocks are called horsts and troughs are called grabens. A spreading apart of the surface causes tensional forces. When the tensional forces are strong enough to cause a plate to split apart, it does so such that a center block drops down relative to its flanking blocks. An example is the Sierra Nevada range, where delamination created a block 650 km long and 80 km wide that consists of many individual portions tipped gently west, with east-facing slips rising abruptly to produce the highest mountain front in the continental United States. Models. Hotspot volcanoes equals. Hotspots are supplied by a magma source in the Earth's mantle called a mantle plume. Although originally attributed to a melting of subducted oceanic crust, recent evidence belies this connection. The mechanism for plume formation remains a research topic. Fault blocks equals. Several movements of the Earth's crust that lead to mountains are associated with faults. These movements actually are amenable to analysis that can predict, for example, the height of a raised block and the width of an intervening rift between blocks using the rheology of the layers and the forces of isostasy. Early bent plate models predicting fractures and fault movements have evolved into today's kinematic and flexural models. See also, Seamount, batholith, continental collision, tectonics, orogeny. Notes. External links: NASA Goddard Planetary Geodynamics Laboratory, home page, NASA Goddard Planetary Geodynamics Laboratory, Volcanology Research, Plate Tectonics. Pictures from UNR, rotating globe showing areas of earthquake activity.